Somewhere underneath the Roman countryside, in modern-day Algeria, there's a tunnel that shouldn't exist. Two crews started digging from opposite ends of a mountain in 152 AD with no lasers, no GPS, and no way to see or hear each other through solid rock. And when they met in the middle, they were off. Badly off. One crew had drifted sideways. The tunnel didn't line up. Water wasn't flowing. An entire town downstream was still waiting on the promise of an aqueduct that, on paper, should have been finished years earlier. So the Roman army sent for a specialist. A man named Nonius Datus, a surveyor with the 3rd Legion, and what he did next, and more importantly, what he wrote down about doing it, is one of the strangest surviving documents from the ancient world. It's an inscription, still readable today, and it reads less like an engineering report and more like a man venting. Because that's exactly what it was. Let's go. Here's the thing nobody tells you about Roman aqueducts. You picture a bridge, rows of stone arches marching across a valley, water gliding along the top, dramatic, photogenic, the kind of thing that ends up on a postcard. And that image isn't wrong, it's just wildly incomplete. Of the roughly 260 miles of aqueduct channel that once supplied the city of Rome alone, only around 30 miles of it, something like 11%, ever touched an arch. The rest was buried. Tunnels, trenches, covered channels running just beneath the surface of the ground for mile after mile after mile, invisible, boring, and almost never photographed because there's nothing to photograph. It's dirt. And that's not a footnote, that's the actual engineering problem. Arches are expensive, they're slow to build, and they're vulnerable to weather, to enemies, to time itself. The Romans didn't build them because arches looked impressive. They built them only when the ground genuinely gave them no other option, when a valley had to be crossed and there was no way to route around it. Everywhere else, they buried the water and left it alone. The postcard image is the exception. The tunnel is the rule. So why does everyone picture the bridge? Same reason everyone pictures Egypt as tombs and pyramids. The part that survives is the part built to be seen. An arch stands in a field for 2,000 years, daring you to notice it. A buried channel just sits there being dirt, silently doing its job until an archaeologist with a shovel happens to find it. We didn't inherit a monument. We inherited the visible fraction of one and mistook it for the whole system. Which brings us to the actual, honestly kind of insane engineering problem underneath all of it. Water only flows downhill. That's not a Roman insight, that's just physics. And it's the one rule the entire system had to obey without a single exception across 50, 60, even 90 miles. No pumps. The Romans understood pressurized pipes and used them in short stretches, but for the long haul, for the backbone of the system, there was no engine anywhere in the chain. Just gravity. And a gradient so shallow it's almost insulting to call it a slope. The aqueduct that fed Nimes, in what's now southern France, dropped roughly 17 meters over its entire 50-kilometer run. Do the math on that and you get an average gradient of about 1 in 3,000, less than half a meter of drop for every kilometer traveled. Modern engineers, when they went back and actually measured stretches of this thing with contemporary instruments, kept assuming they'd made an error because a slope that shallow, sustained accurately over that kind of distance, using nothing but sightlines and levels, sounded less like ancient plumbing and more like a rounding mistake that happened to work. It wasn't a mistake, it was a tool called the chorobates. Picture a long wooden bench about 6 meters with a groove cut into the top and filled with water. A spirit level made of liquid, essentially, that a surveyor could sight along to check whether a stretch of ground was level or how much it dropped. Combine that with another device called a groma, basically 2 crossed arms with a plumb line hanging from each end, used to lay out straight lines and right angles across open terrain, and you have the Roman engineer's entire toolkit for solving a problem we'd now hand to a laser and a computer. Wood, water, and string. That's it. That's the whole technology stack behind 50 miles of near-perfect gradient. And once you understand the gradient problem, the tunnel problem gets worse, not better. Because a bridge, you can build in daylight, checking your work constantly against the horizon. A tunnel, you're cutting blind through solid rock, often from both ends at once to save time. Trusting that your math from the surface will still be true 100 feet underground where you can't see the sky. Can't check your bearings, can't do anything except keep digging and hope the two teams meet. Which brings us back to Nonius Datus and the worst month of his career. Here's what the inscription actually says, and it's worth sitting with because it doesn't read like a triumphant monument. It reads like a man filing an incident report. Datus had originally surveyed the tunnel route himself, laid out the alignment, handed off the plans, and moved on to other assignments elsewhere in the province. Years later, he was recalled because the town of Saldae had spent a fortune and gotten nothing. The two digging crews working from opposite ends of the mountain toward each other had missed, not by a little. The inscription describes the horizontal misalignment as significant enough that when Datus arrived, the local contractor and the soldiers doing the digging were, in his own words, in a state of despair, convinced the whole project was a disaster. Datus resurveyed everything, recalculated the alignment, and personally oversaw the correction, digging additional connecting passages to link the two misaligned bores. He got it done. Water flowed. And then, this is the part I love, he had the whole miserable saga carved into stone and set up near the tunnel, not to celebrate Rome's engineering genius, but essentially to document, on the record, exactly what had gone wrong and how he'd fixed it. It's a maintenance log, a complaint, a cover-your-own-back memo written in marble that happened to survive 2,000 years, while 1,000 triumphant victory arches from the same era just quietly crumbled. Same instinct as a scribe on a broken piece of limestone writing down that a workman was hung over. The monument wasn't the point, the paperwork was the point. It just happened to be paperwork carved into rock, because rock was what survived. Now, here's where it gets good. Because once the water actually arrived in a Roman city, alive, flowing, gravity-fed from 50 miles away, the real fight began. Not against physics, against people. Every aqueduct terminated at a structure called a castellum divisorium, a distribution tank, usually a big stone or brick basin where the incoming water got split into multiple channels, feeding public fountains, bathhouses, the imperial residences, and, for a price, private homes. And the moment water became something that could be divided and allocated, it became something worth stealing. This is the job Sextus Julius Frontinus inherited in 97 AD when he was appointed water commissioner of Rome, and it might be the single strangest job title in the ancient bureaucratic world. Frontinus didn't just manage the aqueducts, he had to police them. His own writings on the job describe an entire underground economy of Romans illegally tapping into the channels with unauthorized pipes, bribing maintenance workers to look the other way, siphoning off public water for private profit, sometimes for entire unlicensed businesses running quietly off a hole drilled into an aqueduct wall. He describes catching landowners who'd punched holes straight into the lead pipework running past their property, just helping themselves. Frontinus's solution was aggressively bureaucratic, standardized pipe diameters, so nobody could claim more flow than they'd paid for. Bronze calibration plugs, stamped and measured, so an inspector could check a pipe's legal capacity at a glance. A dedicated maintenance crew of several hundred slaves and freedmen whose entire job was walking the lines, inspecting for leaks, cracks, and illegal taps. Same pattern again. The grandeur gets you the bridge. The bureaucracy is what actually kept 50 miles of gravity-fed water flowing into a city of 1 million people without the whole system collapsing into theft and neglect within a decade. And the labor underneath all of it, that's worth pausing on too. Building and maintaining an aqueduct wasn't glamorous work, and it wasn't done by senators. It was surveyors like Datus, army engineering units seconded to civil projects, and enormous crews of laborers, a mix of free workers, soldiers, and enslaved people, cutting through rock with iron tools, hauling stone, laying pipe, hand over hand, mile after underground mile, in the dark, by lamplight, breathing dust, for a project most of them would never see finished and would never get their name attached to. Datus got his name on a stone because he was the specialist called in to fix the disaster. The men who actually swung the pick for years in that tunnel, we don't have a single name for any of them. Let's take a step back because there are 3 things here and they build on each other. First, the aqueduct wasn't a bridge, it was a gradient. The arches are the part we photograph because they're the part that still stands in daylight. But the actual engineering achievement, the thing that should genuinely stop you in your tracks, is 50, 60, 90 miles of near imperceptible downhill slope, held accurate with wood, water, and string by people who had never seen a satellite image of the terrain they were crossing. Second, the system survived on paperwork, not marble. Frontinus's bureaucracy, his standardized pipes, his inspection crews, his obsessive documentation of who was stealing water and how, that's the unglamorous machinery that kept the glamorous machinery running. Rome didn't just build an aqueduct once, it maintained one continuously for centuries, against corrosion, against earthquakes, against its own citizens trying to steal from it, and that maintenance is the actual miracle, not the initial construction. Third, we only know about the worst month of Nonius Datus's career because he chose to carve his failure into permanent stone instead of quietly fixing it and staying silent. A man whose tunnel went catastrophically wrong under his original survey didn't hide that. He documented the correction in detail and set it in public view near the very tunnel that had embarrassed him. That is not the instinct of someone protecting a legacy. That's the instinct of an engineer who wanted the next person, whoever inherited this mess in 100 years, to have the actual record of what went wrong and how it got solved. Somewhere under a hillside in modern Algeria, that inscription is still there. Water hasn't run through that tunnel in a very long time. The empire that built it is gone. The province is gone. The language carved into the stone is a language nobody speaks as a first tongue anymore. But the record survived, a survey correction written by a frustrated specialist who'd been dragged back to clean up a disaster and wanted it on the permanent record exactly how bad it had been and exactly how he'd fixed it. We remember the arches because they're still standing in fields, catching the light. We almost forgot the tunnel, the actual harder problem, solved twice, once wrong, and once right, by a man whose name most people have never heard, using tools you could build in an afternoon with wood and rope. So, question for you. 2 crews digging blind through a mountain from opposite ends, trusting nothing but math done with a wooden level and a plumb line, no way to check their work until they either met or didn't. Would you have trusted that plan? Let me know in the comments. Until then, see you soon.